Hey Pacal, this is Alejandro. I wanted to finish up the problems that we worked on today. So first of all, I want to go over the problem about cycling and biking. I came home and I worked on it and I was able to figure it out. So let's read the problem again and see if we can't figure this one out. So the problem says that a woman cycles 8 miles per hour faster than she runs. She cycles for 4 miles and she runs for 2 miles. 2.5 miles in 1 hour. How fast does she run? So the equation that we came up with, and it's the right one, it's that her cycling speed, and remember we gave it a variable of just c, is equal to her running speed, or r, plus 8. Remember, her running speed R. So it says that she cycles 8 miles per hour faster than she runs. So the example that we worked on was if she runs 2 miles an hour, then that means she cycles 8 miles an hour. Or if she runs 4 miles an hour, that means that she cycles 12 miles an hour. Excuse me. So this is the correct fraction. Okay, so what we were messing up on, what we didn't get correct, was the actual formula or the polynomial that we had to use in order to figure out the speeds. So what we had was we needed to figure out her cycling plus her running. That would be equal to 1 hour, right? I think this is the equation that we had. I'm sorry, there's a little bit of glare, but this has cycling plus running, so C plus R is equal to 1 hour. And that, unfortunately, was incorrect. So here's the way it should be. I'm going to write it out, and I'm going to explain to you why it is the way it is. And I'm going to try to stay away from this glare. So it would actually be the 4 miles that she cycled divided by her cycling speed plus the 2.5 miles that he ran divided by his running speed, and that would be equal to 1 hour. Yep, I messed up on the glare, but that says the 4 miles divided by C plus 2.5 miles divided by R is equal to 1. Now the reason it's like this, gosh, I wish I could get rid of that clip. Nope, can't. The reason it's like this is because total that she ran for 1 hour. Now each individual portion basically would tell us the speed of her running or her cycling. For example, if we want to know how much of that 1 hour was taken up by her cycling, well then we do the 4 miles that she cycled divided by her speed, or miles per hour, is going to tell us how many minutes she took up in cycling. Okay, so if she cycles at, I don't know, 8 miles an hour and she cycled 8 miles, then we do 8 miles divided by 8 miles an hour. It took her an hour. I hope that kind of makes sense. We can go over it in person. It'll probably be a little bit better, but just kind of bear with me. So now, once we found this out, what we'd have to do is replace this variable C with the equation that we already figured out for C, which was the running speed plus 8. So let's do that. So we're going to have the 4 miles dividing by her cycling speed, which is the running speed plus 8, plus 2.5 divided by her running speed, and that's going to get us to a total of 1 hour. So now from here, I hope you can recognize that we just have to simply just work with the fractions. So what we will have to do, Pacal, and I'm sure you know this because you did it pretty expertly today when I met with you, is we try to get common denominators. Remember, whenever we are adding or subtracting fractions, we always try to work with common denominators. So let's do that. In order to get this to be a common denominator with this, we'd have to multiply both the top and the bottom by r, because it's the opposite denominator. Now, in order to get the common denominator on this side, we would have to multiply both the top and the bottom by the opposite denominator, which is r plus 8. Okay? So when we multiply this, we get 4r over r squared plus 8r plus, that would be 5 halves r plus 40 over 2. Oh gosh, you can't really see that well. R plus 8r. I'm going to move this a little bit over to the side. You'll be able to see it. Actually, we just scoot it down. There we go. Alright, good. And that's all equal to 1. So we put it all over one fraction. That's r squared plus 8r. At the top, we have 4r plus 5 halves r. Well, let's do that to the side a little bit. 4 is the same thing as saying it over 2 plus 5 halves. That's equal to 13 halves. So this becomes 13 halves r plus 20 is equal to 1. Okay? From here we would want to get rid of this denominator, get rid of this fraction, so we multiply both sides by r squared plus 8r goes away, so we have 13 squared r plus 20 is equal to r squared plus 8r. We combine the fraction, excuse me, both sides, combine the like terms. 0 equals r squared minus, let's see here, minus 13 halves. 13 halves. That's 16 halves minus 13 halves. We get 1 1/2, so that's 3 halves r minus 20. Now when you have a polynomial like this, you could try to factor it if you can. In this case, I don't think we'll be able to factor it. There's nothing that comes to mind. So what you would have to do is use the quadratic equation, which is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So the way I learned it is a song. So it's like Pop Goes the Weasel, it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I learned that in the 8th grade. I never forgot it. Hopefully a song will help you remember it too. So if you plug these numbers into the quadratic equation, you'll get that really weird number, which the answer I think that the book had was 1/4 times the square root of 329 minus some constant number, and that was supposed to equal about 3.78 miles per hour. And that's the way you do it. Now the problem that we had was that way back up here, remember Pacal, we had 4 miles times the cycling speed plus 2.5 miles times the running speed. And that was our mistake. It should have been 4 miles divided by the cycling speed plus 2.5 miles divided by the running speed. And again, the reason why we divide and not multiply is because when we divide the length that she ran divided by the speed that she ran at or that she cycled at, we would actually be able to get the length of time that it took her to run or cycle that. And one of the problems that we mentioned when we were meeting today was that we had two different units of measurements. We had miles here, or excuse me, speed here and time here, or miles here and time here. And we can't have two different units of measurement. So what this allows us to do is it allows us to get time here, and time here. It makes it all constant, it makes it all even, and that's exactly the way it should be. So remember that the length of distance that she cycled or she ran divided by the speed at which she cycled or she ran gives us the amount of time it took her to cycle or run that length of distance. And again, that gives us a unit of time. And since we have a unit of time plus a unit of time equal to a unit of time, everything's in unison, everything's in balance, the world is a happy, lovely place. That's the way it should have been done. So based on this initial equation that we couldn't figure out when we were working together, that's what messed everything else up for us. So what we could do next time we encounter a problem like this is to think a little bit deeper on the problem and see how we can get the same measures of time, same unit of time, the same unit of measurement, whether it be times or feet or distance or volume or whatever it is that they're asking us about. The problem that we had was that we had two different units of measurements, and that's what really messed up our problem. So based on this equation, once we were able to plug in the key formula that we had found out for the cycling speed, it just turns into Algebra 1, which you're pretty good at. The only thing that would turn really ugly, and it's not necessarily hard, it's just a lot of kind of just churning and burning through the numbers, is getting the quadratic equation plugged in and done. So remember, once we had this fraction here, we want to get rid of the fraction. So what we did is we multiplied both sides by the denominator. It's called using the inverse operation. It's divided by r squared plus 8r. So what we do is we multiply by r squared plus 8r. Gets rid of it. We have a pretty simple enough equation, simple enough polynomial. We're not able to factor it, so since we're not able to factor, we have to default to the quadratic equation. Based on this, we were able to get an ugly number over here, which then was going to turn into our answer. So I hope that makes sense. If you have any questions, give me a call, shoot me a text, send me an email, whatever you like, and I will see you next week. But I'm going to see you one more time because I still have to go over the second problem that we're stumped on.